So,
Yes.
hello everybody. You all are able to hear me? Anybody can respond. I am audible?
Yes.
Yes, sir, you are
Yes.
audible.
Okay, good. So far, we have studied, what are things we have studied so far? On research methodology, I told we have 6-step processes. So out of that, we have so far done 2 steps. First one is formulating and clarifying a research topic that we did. The next step was literature review. In the last lecture, we did that. Basically, how you look into the literature and what are the sources, and how we can write a review report. That was the main objective of telling you all those things yesterday. So that when you start your PhD, your topic, after deciding your topic, you do a good literature survey and then try to write a review article where you can mention all those gap areas that you have found in your research topic, and you can suggest possible experiment that can be done in the future. That was what I will impress upon you all, that you all should aim to write a review article before you start your research work. And today we will take up the third step, that is research design. And following steps we will learn today. One is why research design, why you need the charter. Then second step, we will discuss a little bit about research philosophy. Achha, all of you have seen my handwritten note we uploaded. Any of you can respond? You have seen that? And any of you can respond yes or no. Or if you are not seen, then do look into that if you feel like, or if you have enough information you are getting from the class, then it is fine. Yeah, first step we will today discuss why research design. Second thing we'll discuss what is research philosophy, and we'll also talk about scientific reasoning. Scientific reasonings we use doing research. Then also we'll discuss some of the important concept related to research design. Then finally, we will see various research methods used by scientists to carry out their research. So these are the basically today's class learnings. That's what we will learn today. The problem that follows after defining research problem, once you have defined your research problem, the most formidable problem then comes is to preparation of the research project. That means basically, which is popularly known as research design. So once you have decided about the topic, then the next most difficult thing is to design your research project or your design your research. Like when you build a house, suppose you want to build a house, the first thing you have to do, you have to get a architecture and ask for a design. I want to have a house with so many bedrooms, so many toilets and things like that. So then he will make a drawing for you, a design for you, and then only you go to a some sort of a contractor or something who will build a house for you. So similarly in the research, the overall strategy that you choose to integrate the different components of study in a coherent and logical way, thereby ensuring you will be efficiently address the research problem. So you have to choose to integrate the different components of the study in a coherent and logical way. It constitutes the blueprint for collection, measurement. So what I can say, it constitute the blueprint for the collection, measurement, and analysis of the data. So your research design, which constitutes the blueprint for collection, measurement, and analysis of the data. Then let me tell you something about research philosophy. Whether you are consciously aware of them or not, every stage of your research, you will make number of types of assumptions. When you do experiment, you make a lot of assumptions. These assumptions inevitably shape how you understand your research. A well thought out set of consistent assumptions will constitute research philosophy. How well thought out set of consistent assumptions will constitute research philosophy, which will underpin your research design. So the type of assumptions you make, that will underpin your research design. There are certain key concepts in research philosophy. So something is what is called ontology. Ontology means what is reality. So this can have two thoughts. When, like in all this scientific research, we say that only one reality. Reality is only one. And that is one total accurate description explanation. Only one way you can explain a process in a correct way. There is only one reality. But in certain fields like social science, for that matter, you have more than one reality. It depends on the perceiver. Like, sometimes you must have seen a, illusion picture. Yes, if from some angle you look it will look like a rabbit, but some other angle it will look like a woman. So, it has same picture of more than one reality. So basically, when you are studying social sciences particularly, this thing can come. Reality can be more than one, because the world is not separable from our thought. The world is not separable from our thought. There are multiple realities. And one thing is ontology, the other thing I think is epistemology. But when you are working in science domain, you are here. Only one reality. The truth is one. And we are trying to look for that. Episto, what it says, how do you know how do you know what you know? This is the question. How do you know what you know? So ontology is basically about reality. There are two school of thought. One is only one reality. Other is more than one reality or multiple reality. And similarly, how do you know what you know? Here also you have two. One is quantitative. You can say this is quantitative and this is qualitative. I'll write. Quantitative means knowledge can be measured. Knowledge can be measured. So by some, you can acquire the knowledge. And how much knowledge you have acquired, it can be measured by measured by a reliable tool. And when it is qualitative, you say can be interpreted, not measured. Can be not measured. This is more applicable to social science, because our observation of the world are influenced by our conceptual baggages. Because same issue in a social issue, people can look from, people can interpret in a different way. So that is the epistemology of research. It has, it can only be, there is no single reality, only it can be interpreted. When using scientific reasoning, two different approaches are followed. I think earlier also we discussed. For scientific reasoning, one is called what is deductive reasoning, or also you call it positive reasoning. In this case, it is also more towards quantitative analysis, Where a theory is well established, we decide our hypothesis and carry out an experiment and prove the hypothesis. So if you have a well-established theory, then you decide, develop a hypothesis and then carry out a experiment and then prove the hypothesis. This type of reasoning is known as the deductive reasoning. So if you start with theory, then you go to hypothesis, then observation, then confirmation. So there is another approach to reasoning, which is known as the inductive reasoning. It is deductive, then inductive. In this case, it's mainly qualitative. It starts with observation. Then you observe a pattern. Then you develop a hypothesis. Then theory. You can yourself check your research topic you have chosen is a deductive or inductive reasoning. So this maybe you can check what type of reasoning you are using for your own research. So let me also tell you some of the important concepts. This is the, I think, third point. Yeah, scientific reasoning third is over. Then we are in the fourth point. Some important concepts. To research. Okay. There is something called dependent and independent variable. This you must remember what is dependent and independent variable. Variable, what is variable? Variable is a concept like a height, weight, income, which can take different values is called a variable. Any concept that can take different values, get back the screen. Any concept that take different values is known as a variable. It can be continuous or it can be discrete. Like your age can be continuous. Discrete means a variable like the number of children in a family. That's right. So if one variable depends on other variable, it is called dependent variable. Then comes dependent variable. So a variable that depends on some other variable is called a dependent variable. Then something called what is extraneous variable. Independent variables that are not related to the purpose of the study. Suppose you are carrying out a research study and you are one independent variable and you have one dependent variable. But there is another variable which you are not concerned. What may affect your dependent variable, like volume, pressure, and temperature. So it may affect your dependent variable are termed as the extraneous variable. It's a variable that we are not interested in your study, but they can affect your dependent variable is known as extraneous variable. Then something called control variable. One important characteristics of a good research design is to minimize influence of effect of extraneous variables. It's control variable. It's an important characteristic of a good research design is to minimize the influence of or effect of extraneous variables. The term control is used when we design the study to minimize the effect of extraneous variables. You design your experiment in such a way that you minimize the effect of extraneous variable on your dependent variable. That in that situation, it is your variable is called or independent variable is called control variable. You are controlling that variable. Then something called confounded relationship. When dependent variable is not free, you try to make extraneous variable, control that. But in fact, in spite of that, if the dependent variable is not free from influence of extraneous variable, the relation between dependent and independent variable is confounded with extraneous variable. You always like to, extraneous variable, you always like to influence, you like to minimize. But in certain cases, maybe you're not able to do, then the influence of this extraneous variable on your dependent variable is confounded with your dependent variable is confounded with extraneous variable. So these are the terms sometimes, when you discuss about research method, research design, these terms are used. So now we'll see what are the different research methods scientist has been using over the years. Though science starts with curiosity about the world, but while curiosity is necessary for science, it is not enough. Science also depends upon logical thought, careful planned experiments, mathematical and computer models, specialized instruments, and many other elements. So scientists spend a lot of their time in using a wide variety of research methods. So today we will discuss some of these research methods that are being used by scientists. So one of the research method, the first one, let me write, is what is known as hypothesis driven What is a hypothesis? A hypothesis is a statement about the world that can be true or false. It's a statement that can be true or it can be false. And when you test a hypothesis means you are trying to investigate this statement, whether it is true or or false. That you want to test. Hypothesis-driven research is it's only applicable when there are only two options, true and false. So what are the steps in this method? What are the steps followed in this type of research method? Like for example, if you want to study eating 2 ounces of olive oil in a day decrease the odds of contracting heart disease. Suppose this is your hypothesis. You want to test that. Then you can check by randomly assigning large number of people diets which contain olive oil and some people that does not contain olive oil, and then do a study. So hypothesis driven research is basically mainly done in bioscience. So normal steps we follow is first you state a hypothesis. Then design an experiment. Maybe in this example, you can select randomly people and give them diets with olive oil and not olive oil. That is will be your experiment. The design an experiment to test. Then 3, construct any necessary apparatus. Perform the experiment. Then analyze the data. You have to analyze from the experiment to determine how likely it is the hypothesis can be disproved or proved. And then you refine or correct the hypothesis and continue if necessary. Usually hypothesis, you have to always, your first, in this case, the example I told, eating 2 ounces of olive oil a day decrease the odds of contracting heart disease. This is a hypothesis. Whether it is false or true, then you can carry out a study and do. And as I told you, this type of research method is applied when you have only 2 options, yes or no. But when there is a multiple options available, at that time you can't apply this one. There are other research method you have to do. The next research method is measure a value. In this case, suppose measuring a single number, measuring a value means a single number, is often much harder than it seems. Some of the primary challenges in measuring values have to do with errors in the measurement process. Suppose you want to measure mass of the electron neutrino, even beta spectrum. This neutrino is basically the most plentiful particles in the universe, but it reacts very rarely with ordinary matter and is therefore almost invisible to us. So, measuring a few numbers underlines many of the most expensive large group projects in the science. Some of experiments, big experiments, are really to measure measure a certain value. Like experimental particle physics. You want to measure, like a Higgs boson, a whole of a large hadron collider in a CERN accelerator project, where thousands of scientists work together, was just to prove that there is a Higgs particle. So now also nowadays, gravitational wave measurement. A lot of people are working on that just to detect a gravitational wave, because that was predicted some almost 100 years back. You want to measure that. But sometimes, government agencies like to fund project of this type. This type projects are sometimes, easy to get funding, um, uh, because this type of simple, the success of the project is almost guaranteed, because you want to measure something. So the success is guaranteed. But it has also certain good points. Measuring a single value is often the starting point for testing a hypothesis or measuring a series of related values. A single value, then that may lead to you measure many more values, and that may open up a totally a new field. So measuring a value is some sort of this is experimental. I would say experimental one, type one. So how do you, what are the steps is followed in this case? Again, you identify a well-defined quantity. So whichever thing you want to measure, design procedure to measure. Perform experiment. Analyze and report on the accuracy of the result. Because measuring a single value is much harder than it seems, because that's the primary challenge in measuring the value have to do with the errors, because like neutrino, electron neutrino, though they are plenty, but their interaction with the normal matter is very low. The cross section will be very low. Background will be too high. So your result will have a lot of errors. Then analyze and report. Report on the accuracy. The results. Even today people are measuring beta decay spectrum, so endpoint energy, and they are designing a new type of experiment so that they can go to minimum. You don't allow this guy to come in because he's coming so late. Don't allow. Anybody? What is his name? Harsh something. Harish. Harish, can you respond why you are coming so late? Harish. I had told once that anybody coming after 10 minutes, you will not get him in. So ask him to reply. Is in YouTube or in WebEx? Harish, can you hear me? Yeah, let me ask him. Harish, you have to respond, otherwise you will remove from the list. You're not responding, no? Harish, can you hear me? You can't come to class after 40 minutes. You don't do this. No, why you are not? Who is this fellow again? You let him in and will ask him. Rajeshi Roy. Rajeshi Roy, can you hear me? You can unmute them.
एक्सेप्ट करने चाहिए रिक्वेस्ट
Rajesh Rai, why you are joining now after 40 minutes? So let us mark these two names, Rajesh Roy and Harish. Okay, note down. We are not you can't come, you can't do like this. I have told once, anybody coming after 10 minutes, we will not take his attendance. If you want to attend the thing seriously. Otherwise, if you are not interested, it's all fine. But you don't come and interfere in between. Okay. Analyze and report on the accuracy of the result. So this is this type of research you do, measuring single value. Like these are normally very big experiment. A lot of people participate on this. Then the next type of experiment is measuring a function. Measuring a function or relationship. This is again experimental research. So most of the experimental physics and chemistry operates according to this research method. Most of the physics and chemistry operates according to this research method. In this case, what you do, observe a phenomena and develop testable question. First, observe a phenomena and develop testable questions. Identify the control variable. Identify the control. What are the control variable? That means what is depending on what. Design experiment. Then accordingly you design experiment to vary the control variable. To vary the control variable. Measure the response variable, that is dependent variable. You vary the control variable and measure the response variable, and keep other factors constant. That is like all the extraneous variables, you keep them constant. Then you perform the experiment. Analyze the relation between control variable variable and response variable, and characterize the relation mathematically. Then you do some sort of a polynomial fitting or something. You characterize the relation mathematically. So this type of most of our research we will see is revolves around this, measuring a function or a relation. Suppose you do an experiment, I measure a cross section, reaction cross section I measure, and then there are some standard theories. They also will predict cross section, and then I try to compare my experiment with the theoretical predictions. And then any difference I see, then I find some physics. What is the reason why there is a difference? Or if it is matching, then you can say, okay, because of this, it is like this. So most of our research are around this type of research design, measuring a function or a relationship. Next. Then there are another type of research method, that is construct a model. This mode of research describes much of applied mathematics, theoretical physics, theoretical chemistry, theoretical biology, and astronomy. In this type of research method, steps you follow is choose a relationship discovered through experimental investigation. Suppose you have observed something through experiment, then you, second point is you construct a mental picture to explain the relationship. Earlier research method, we are trying to measure a function or a relationship. Sometimes you do experiment, then you find certain relationship. So you take that, choose that relationship, and then you construct a mental picture to explain the relationship and develop hypothesis about origin of the phenomena. Then you yourself develop a hypothesis in which way I can get this type of relationship. Then identify basic mathematical equations from which the relation might result. Many times, certain phenomena people use a diffusion equation because the process is such, you can treat that whole process as a diffusion process. Yeah, somebody else has also come. Kushal Kumar Ram. ये तीनों का नाम नोट करो and we will remove their name. You allow him to come in. Kushal Kumar नाम याद रखो तीनों का. Kushal, I will talk to you after the end of the class. You can't do this again. You can't come after 50 minutes. Do you think we are joker here? You can come anytime and go anytime. So I will talk to you just after I finish my lecture. You are disturbing in the middle of the lecture. Yeah, you construct a mental picture to explain the relationship you have discovered through an experimental investigation. Then identify basic mathematical equations from which the relation might result. Using analytical or numerical techniques, determine whether the experimental relationship results from basic mathematical equation. So from your the equation you have developed, through that equation, whether you will able to develop a relationship from the basic mathematical equation you have taken. If correct, if incorrect, find a new mathematical starting point. Otherwise, you take your if correct, predict new relation. You find that your mathematical equation what you have taken, that is able to explain your relationship that you have discovered in an experiment, and then you also your theory is able to explain the one observation. Then you have a good chance you can predict many more relationship between various variables. And if it is incorrect, then you change your mathematical starting point. And if it is correct, then you predict more. That is what is done in a construct a model type of research method. And for example, you can say experimental observation of intense burst of gamma rays. It was observed. Then you can develop a hypothesis that this gamma ray burst might have emerged from gravitational collapse of certain stars. Then you can develop equation and then see whether you are able to predict through your mathematical equation gamma ray burst. So then the next one is a observational and exploratory research. All these earlier research methods that we discussed. So the variables you can control, but when it comes to another person has come now, Anuram Pal, you note him, huh? Just you will remove these names. No, Abhiram, we get them in, but then you will remove. You have to talk to them. No? Anurag Pal, you must wait. I would like to talk to you after this class. So you have come after 50 minutes of the class is over. We don't recommend this. Okay, you must be courageous to be there and talk to me. Okay, observational and exploratory research. This research is different from all other type of research methods we discussed, because here you have no control over the variables. This mode of research covers an enormous range of possibilities. Many research projects contain an exploratory phase. Many research projects, first they do exploratory, which produces something of interest that then became the project of other research methods. Same example, we can take observation of gamma ray bursts. The observation triggered a large and a long-term research effort with both theoretical and observational components. Like in this type of research, what you have to do, you have to create an instrument or a method for making observation that has not been made before. That's one thing you have to do. You have to, but a very special instrument measure. Carry out observations, recording as much detail as possible, because you have no control value. Whatever you are seeing, you have to just record them. Searching for unexpected objects and relationships. Then present results, stimulate further research. So you see, in India also we have one new telescopes. They are coming. They are there. One is GMRTC, Giant Meter Radio Telescope, that is at Pune, and another one is a Major Atmospheric Cherenkov Experiment Telescope, that MEST telescope at Hanle. They are very unique facilities to study this observational and exploratory research, because they help you to, they open up new avenues, new field for your research, because this is observational is unexplored, nobody knows, and there is a scope that you observe something for the first time, so then that opens up new fields. And then the next one is improve a product or process. This is industrial or and applied research. Suppose this is create a device to make light from electrical current. known as Thomas Edison, he made the bulb. So physics was known. Electric current, when he was trying to look for a material, uh, when electric current will pass through, it will really give a glow so that it should give light. So in this case, your steps you follow is identify the market needs per product. Because you remember Thomas Edison time, people must be using only oil lamps, and at that time, if this electricity can give light, then it was a great thing. So it was a good, now like bulb is something that everybody is using all over the world. So identify market needs for the product, design product with potential to meet the need, then build prototype products first, then determine whether products function as desired, optimize product with respect to cost, speed, environmental consequences, and other factors that affect profit, bring product to the market and continue. This is the improve a product or process. This type of research mainly done in institutes, big institutes, like BRC. You may find this type of research is done. Improve a product, DUCT, product or process. So after this, we have I can just group certain things. Allied area of research. There are many additional skills and areas of research possible. So maybe one is pure mathematics. Most of the science cannot be practiced without mathematics, and much of pure and abstract mathematics was developed because of the desire to solve scientific problems. However, research in pure mathematics is sufficiently different from scientific research listed we discussed above. So research in pure mathematics is different from scientific research we discussed above. And hence this pure mathematics is treated as allied area rather than a part of science. Developing a pure mathematics means developing conjectures about relations that might be true, defining new entities, and proving theorems. It is extraordinary that such an elaborate body of knowledge has developed from nothing but pure thought. Mathematical research is pure thought. So last but not the least, in the allied group, I'll put computer and computer science. Computer has changed the way science is practiced in many ways. Computational science is arguably a branch of science distinct both from experiment and theory. Computational science are very popular these days. They are pretty different from experimental and theoretical research. So in case of computer, we have improving the hardware that lets computer continue to become faster, involves many different fields, but mainly electrical and electronic engineering. Then thinking of new ways to organize computers and new ways to program them is a domain of computer science. Basically, thinking new ways to organize computers and new ways to program them in the domain of, this is what is the basically the domain of computer science. Computer science has its root in formal logic and discrete mathematics, but has now become a separate discipline with its own goal and standards. So, yeah, with this, now we have discussed various research methods that are being used by scientists all over the world. So I hope that I have covered almost all the methods. If anything remaining, you can mention and we can discuss that. So today's lecture note you will find in Anuvidya, it will be uploaded. Again, it is a handwritten, and if you find it is useful, please go through it, and it will be available to all of you. And now I will only ask anybody. Rajesh Roy, can I talk to you? Is in YouTube or Webex? Rajesh Roy. Rajashri Roy, SINP Kolkata. Can I talk to you? And some Pal was there. Harish and Rajesh Roy and Arun and Pal, somebody. Rajesh Roy. Left. Rajesh Roy, can you? I don't know why you are not responding. You are able to hear me? Anybody can reply? Hello?
Yes, we can use chat, sir.
Okay, you are able to hear me, no? Okay. Okay, let him in. Anuram Pal, no? Anuram Pal, can you hear me? I just want to talk to you. So you note down these names, Anuram Pal and yeah, before we stop, let me tell you, next two classes will be delivered by my colleague, Professor Siliguri. He will be talking about ethics and plagiarism in public research and publication. Because for the next few days I am out of station. So again, I will come back on 6th March. 6th March onwards, I will take your class. But next two classes will be taken by Professor Siliguri. So anybody has any question? So what you do, you can remove those names. Huh? Just remove the names. If they are not responding, then what we can do? Their attendance will remove. Rajeshri Roy, I will ask her once more. You just keep that. Rajeshri Roy, 6:40 she has entered. Rajeshri Roy, can you respond? SINP Kolkata. You just respond. It's not good, no? Huh? And Harish. Yeah, Harish from which place? Suppose somebody is getting once disconnected,
Yes, sir.
then also this thing happen.
Yeah, somebody is disconnected and rejoin the lecture.
Whose time it will last for?
Then it comes.
Maybe that was the reason. YouTube, any question you? Okay, if you are not asking any question, then we will stop here. And today's handwritten lecture will be available in Anuvidya. Any of you wants to look into it, you can look. Okay, thank you. On camera.